Hi class. This will be a topic on Lagrange multiplier. Alright, so what is Lagrange multiplier? The aim is we would like to improve the amount used of algebra in the calculations, where our objective is to compute the minimum and maximum problems. Let's straight go to the example. A wire is bent to fit the curve y equals to 1 minus x squared. Look at figure 9.1. A string is stretched from the origin, this point, to a point xy on the curve, or somewhere on that curve. The question will be find the minimize or the point fx to minimize the length of the string. So the aim would be we want to find the minimum length, or in this case they don't even tell you in an obvious manner, where we are looking at the relationship of a distance. D equals to square root x squared plus y squared, or you can also rewrite as d squared equals to x squared plus y squared. This is, let's say, because it's the functions of x and y. But let's say if you have some distance respect to a 3D, then your dx is x squared plus y squared plus z squared. So note that your x and y are actually dependent, where they are related to this what they call a constraint functions. So in this case, it's the functions of y equals to 1 minus x squared, or you can rewrite them in this form, where these functions or the constraint functions is actually equal to some constant. So you see here, it's a constant. So this part, y plus x squared, is functions of phi in two variables. Now, if you would like to solve the minimizing the problem's functions of f, in this case the distance, okay. So in this case, you may write x squared plus y squared, okay. Or you can write it in terms of, because of the squares, this is square, then you can just take the square root. And then you can find the f dx equals to 0. Then you can compute x if it's for one variable. So if there are two variables, you do the total derivative. So you find the partial x dx. You have the first term and second term for two variables. This happens as well for the case of the constraint function. Okay, so if you have three variables, then you have to add this one. You have to add fz dz equals to 0, and you have all the rest. Okay, we introduce this lambda, okay, where we call it the undetermined multiplier that can help us with the calculations. Okay, now let's solve the following. So the distance, you can use this from d squared x squared plus y squared, but you can always take eventually the square root all those, but it's just algebra, so it's easier to take this form. And your constraint functions is, so you have equation 1 in red, equation 2 in red. So what you do with Lagrange multiplier, you use this lambda undetermined multiplier. You write down the total f with uppercase F as fxy, and then you add the one that you want to minimize. You want to find xy that you want to minimize, and you multiply your lambda with the constraint functions phi. Okay, so you got the first term and you got the second term. So what you do, you substitute in this formula. So I put this equation star. So you do the first derivative, partial derivative respect to x respect to y. So 2x lambda equals to 0, 2y plus lambda equals to 0. And then you choose the constraint functions. So you have these three 3 sets of equation. So you're going to solve all these 3 sets of equations to find a point x and y. So for example here, from number 2, from equation 2, I take lambda equals to minus 2y. Then I substitute in equation 1. Okay, so after I did it, then I arrive at this point. Okay, then you can see either your x equals to 0 or your x equals to plus minus square root half. Okay, it's just by factorizing. And then you can find each of x, the point of y. So if your x is 0, your y is 1. If your x is plus minus square root half, your y is half. So if you want to see whether it gives you the minimum, so which point that gives you the minimum, so you choose this point. So let me do this in green perhaps. So 1, 2, so this is 1 and 2. So you apply with the fx. Okay, so if f0, 1, so this is f plus minus half. Okay, so you can see that if you do that, so eventually the d is you square root 1 give you 1. Okay, and for this one, if you have d square, so because of distance, so you can just, your d is square root 3, 4, so square root 3 half. So which one is smaller? Definitely this one. That is your Lagrange multiplier. Thank you.